So let's get started. So hello everyone, uh, where you are. Welcome to the CelerData webinar. So today we're going to talk about what CelerData has done in the last quarter, around the last quarter, right? So I am Sida Shen. I am a product manager here at CelerData. So now let's get started. So before I actually dive into the features and the demo, I'll first give a very quick rundown of what is CelerData and, specifically like the open source project StarRocks as powering CelerData, right, in the back, right? So some of the use cases and what it's good at, right? So first you can use StarRocks as a real-time data warehouse, right? So it has a very simple architecture. FE and Shen has no external dependency. It's based on StarRocks' own file and table format for the best possible performance and for real-time mutable data. You can get like sub 10-second data freshness with like data upserts and deletes things, right? So very good performance built for customer-facing like workloads, right? Storage and compute separated architecture is cloud native, so you can scale, without losing data. There's a cache there, to optimize, to make sure you have the best performance. And the standard SQL support a standard SQL, MySQL client. You use that to connect, and also it has Trino dialect support, right? And then you can use StarRocks as a data lake or lakehouse, open lakehouse query engine, right? You can buy just dumping the StarRocks storage engine, replace that with a open table format, with files, Parquet files governed by like an iceberg table, right? You can use StarRocks to directly query that piece of data and still get, customer facing level kind of performance, right? It natively integrates with open lakehouse table formats like Delta Lake, Iceberg, and Hoodie, and Pyman, right? And with open catalog services, and like Unity catalog we're going to talk about today, right? You can get data warehouse performance on the data lake, right? It's still the same, even simpler architecture with no external dependencies, and standard SQL Trino like support as well, right? With this setup, right? And StarRocks, as simple as it is, it's a very light software compared to other similar solutions, right? In terms of has no external dependency, but managing that can still be expensive, right? You still have to consider the cost of actually maintaining a whole like open source data warehouse or query engine by yourself, right? First, you have to consider like managing the infrastructure on-prem or on the cloud. It can be expensive. It's stateful. It holds a lot of data, right? So it's very expensive to maintain, right? And StarRocks has some rudimentary security and access control. It has, a RBAC system, but no like more sophisticated something like column masking, right? It doesn't have that, right? And scaling wise, you have to manage that yourself, right? Or use the StarRocks Kubernetes connector, right? If that's your environment, right? And also with resource isolation, StarRocks doesn't really have a kind of like a hard resource isolation way, a way to isolate your workload. So it's not really, so it's going to take some work, if you want to use it in a very complex, heterogeneous kind of, environment, right? And ecosystem integrations as well. StarRocks has great integrations with other open source kind of products, but not that much with commercial ones, right? And here is where CelerData Cloud come in, right? So majority of the feature we're going to introduce today are on CelerData Cloud BYOC, right? So bring your own cloud version of CelerData Cloud, right? So basically, you have your enterprise cloud managed StarRocks in your own VPC, right? So CelerData is going to have a kind of like a cloud manager kind of layer in our VPC. So we're going to do the maintenance, remotely, right, in your VPC. So you get ownership of all of the data, all of the infrastructure, and you get the benefit of a cloud managed solution, right? So and has a pay-as-you-go cost structure. So you get charged by the second. Has advanced security features and access control. We're going to talk about some of that today, right? Some new features around that, right? You have the option to do everything graphical, if that's your thing, right? And other, advanced features and integrations such as, Power BI, right? integration, right? And it's maintained by the initiator and the maintainers of the StarRocks project, and has SLA that's guaranteed, right? So now let's get started. Took like 5 minutes. That's good. So now let's actually get started. So what's new with CelerData Cloud BYOC? Okay, so there are 5 main like categories I want to talk about, right? So first is ecosystem, and we do have the Unity catalog integration that was introduced in the very recent release, right? And automation wise, StarRocks Materialized View has been a feature um, that a lot of our users loved, but certainly it does require some knowledge to get started, right? And we introduced a automatic MV to help the users to so everyone can benefit from the power of Materialized. We were going to dive a little deeper into that with the demo today, right? And security-wise, we supported data encryption, transparent data encryption, right? And high availability, we have failover groups for our share nothing architecture, and also we have cost efficiency kind of or cost efficient kind of features, like we have just introduced compute auto scaling for our shared data architecture, and storage auto scaling for for shared nothing architecture. We're gonna take a look at each one of them. Okay, so first, ecosystem integration, right? Unity catalog. Unity catalog was open sourced by Databricks just a while ago, right? During their Data AI Summit, right? And we've been partnering with Databricks since then. And on CelerData Cloud BYOC, we just announced the integration with Unity Catalog open source and Unity Catalog managed version. That's on Databricks, right? So Unity Catalog has like kind of like 3 like value pillars, right? So first is it's open, right? It's completely open sourced, and according to our experience, the open source version is compatible with the managed version, right? And also it can interrupt. It has interoperability not only between the compute engines, also with different table formats. That's through the Delta Uniform API, right? And also you can have your governance across your data and AI applications, right? You can have Unity catalog governing your SQL workloads, as well as your something like your ML flow workloads. That's pretty cool. So we just had a webinar with the PM owner of Unity catalog on our CelerData webinar around like 3 weeks ago. You can go to YouTube and check it out, right? And there was a demo that showcases how you can manage both CelerData, use that for customer facing like workloads, and ML flow, right, for machine learning kind of workloads. Govern that together in one place, right? That's fantastic. And here is how it works. It's a very simple. It's just an external catalog, right? And it's a native integration, so it works with if you want to connect it as a iceberg, through the iceberg REST catalog, which the StarRocks one can also do, right? Or you can just natively connect as unique catalog through that SDK, right? Both of them works. So definitely check this out in the documentation and give it a try. Okay, so next is security, right? Transparent data encryption, right? So we added encryption capability inside of CelerData Cloud BYOC, right? It's from encryption in transit to at rest, right? From server side to client side, now we have everything supported, right? And this encryption, it doesn't add that much overhead, around 10%, right? Less than 10%, according to our tests. And you can connect to any kind of key managed service you trust, and the key can automatically rotate, so you don't have to actually worry about that, right? And go check this out as well. And also cost efficiency wise, we added compute and storage auto scaling. I'm going to talk about those. And first is preview feature, compute auto scaling for our elastic clusters, right? So this is the one thing that a lot of users has requested, right? So we added this feature to automatically scale your compute warehouses. Each one of your compute warehouse, you can configure them like separately based on your CPU utilization and your CPU utilization over a certain threshold, over a certain threshold number of seconds, right? It's gonna basically scale within that warehouse, add more nodes within that warehouse, right? And it's a preview feature, so it's very suitable for those, I would say, like query only workloads. If you are on a kind of like a lake house, right? You don't ingest data, and query only workloads ad hoc, and that has kind of like a peak demand and lower demand, and something like that would be very suitable for computer autoscaling, for you to help you save some of the costs, so you don't have to maintain the highest number of configuration of the warehouse at all time, right? Only when you need it. Okay, so that's compute autoscaling for elastic clusters. And now this is the second one is storage autoscaling, right? This is for classic clusters. So this is when when your FEMB disks are full, right? So it's able to automatically increase the storage size, right? And this comes really handy, because like when storage is full, I mean, things go really, really south, right? Yeah, so definitely go check this out if you're on the classic cluster. You can add this directly on the console. And then it's high availability and disaster recovery, right? Failover groups. So this is mainly for the shared nothing architecture, right? So let's imagine without this. So what you would have to do, right? You would have to maintain another cluster if you actually need high availability, right? Very high availability. You cannot withstand any downtime, right? And sync the data there yourself, right? Or you have to like spawn a new cluster and somehow get the data in there, right? But this feature allow you to have two different clusters within one CelerData account, and then connect them, right? Basically, you have a primary cluster and a secondary cluster. So the primary cluster is going to periodically sync all of its data to the secondary cluster, right? So when some event happens, you can go on and manually, with one line of command, switch everything to the secondary cluster, right? So definitely enhances recovery time, if you are willing to spend that extra cost, of maintaining a second one, right? And minimizes data loss and simplifies your management and ensures the highest availability that you can. Okay. And then automation and ease of use, right? So here is automatic materialized view, and this is probably the biggest one, out of all of the releases. So before we actually dive into like how our auto materialized view works, let's first talk about, like, give a quick refresher of what the problems like materialized view solve and what that thing actually is, right? So there are challenges with ETL pipelines today, we see, right? With let's imagine you use something like a Spark, right, to do your ETL jobs, right? Something, if you're a data engineer, you identify a slow query, right? And if the only way of solving, or the best way of solving that slow query is through a pre-computation, something like a pre-aggregation or denormalization, right? So you would have to write a Spark job and do the denormalization right here. But that's not the end of it, right? You still have to rewrite the SQL to point to the new table, right? Whether you do it or the user has to do it, or you have to create some kind of like automated application that does it, right? But it has to be done, right? And this actually forces a lot of engineers, a lot of the users, to figure out all of the data pipelines, prior to developing, class application, right? So figure out all of the denormalization, before actually building the whole thing. And this process is very time consuming, a lot of planning, so it definitely lengthen your development cycle. And also when they plan a little more, and mostly like a lot more than they need, so they're wasting resources building pipelines that generates tables that actually never get used, right? So we created materialized view, right, within StarRocks. So StarRocks materialized view, it can do all sorts of things. It can do multi-table join, it can do aggregation, it can, incremental refresh, and those are not as important as its full query rewrite capability. So you don't have to change a single script, to benefit from the materialized view, because StarRocks cost-based optimizer can actually reroute your new SQLs to the most appropriate materialized view to accelerate that thing, right? So you're able to have the flexibility of adding materialized view like after adding pre-computation after you find a slow query, right? So you have that flexibility and way better experience for a data user, because they don't really feel anything, right? And it definitely saves compute and storage from like those unnecessary pre-computation pipelines you would have built, right? So you end up going production way faster, right? But StarRocks materialized view is not a simple, it's a powerful feature, but it's not exactly a very simple feature, right? So you do require certain knowledge to fully utilize its potential, right? First, you have to understand the query pattern and data distribution, right? So you know like which query can be optimized by what kind of pre-computation, right? And also, you create the pre-computed table. You have to know like how to partition that table, right? And that's something you need to think about as well, right? And second point, I think this is actually the most important point. So the power of StarRocks materialized view lies within the query rewrite capability, right? But query rewrite is just not a silver bullet. It doesn't rewrite just every single thing, right? You have to understand the SPJG limitation, right? You have to understand like when to use a view-based rewrite, when to use a text-based rewrite, right? To create, so you can actually create materialized views that can be efficiently rewritten, right? By StarRocks. So that's another challenge that's there. And also third is you want to design generalized materialized views. I think this is the most difficult one, right? You don't want one materialized view to just accelerate that one query, right? You want something that's optimal, right? Just the right amount of materialized view to accelerate all of your queries so you get satisfactory performance, right? Because having too many materialized views is actually not a good thing, right? Refreshing is very expensive. Storing those materialized views is very expensive. And also having too many materialized views can really, our cost-based optimizer, when it's trying to do the rewrite thing, when it's too many of them, it actually can take a little too much time, right? It can actually slow down performance sometimes if you have just stupid amount of materialized view without actually without considering, right? So here we introduce a public preview feature called automatic materialized view. So what this does is that it's able to recommend a materialized view that just works, right? A materialized view that is able to be rewritten, guaranteed rewritten by the cost-based optimizer, right? It has the right partitioning, right? And it's generalized enough, and you can even tune that, more materialized view or more performance, right? So so you don't have to worry about all of those and just focusing on on the business side of things, right? So basically, how it works is that you just have your historical queries and just pick the ones that you like and put that into a tune space, right? And CelerData Cloud BYOC is going to take those queries, study those queries, and recommend batches of materialized views, right? You can pick from, right? And then you take a look at the materialized views. If you like them, just push them online, right? And when new queries come in, the optimizer can automatically rewrite the query and you get the result way faster, right? So accelerates a lot more query, a lot more easy to use, right? And dramatically lowers your total cost of ownership for your entire infrastructure, right? So here, let's take a look at a demo, prepare the demo for the AutoMV, right? So first, let's just go over the demo. So this demo is on a rather simple data set, the SSB data set. So it's a very small version of SSB because the materialized view does take some time to recommend. So we want to see that interactively, right? So there are like two small scenarios I want to show. So first is automatic materialized view recommendation, right? So how to generate 100% rewritable materialized views with with a full create statement that you can see, right? And then we're gonna see with that, we're only also going to see that, how CelerData Cloud BYOC can generate materialized view that accelerate just more than just query, more generalized materialized view, right? And then you see the partition recommendation in real time as well, right? And the second little scenario is that if you have many materialized views that might look similar, right? There is actually a way to merge those materialized views into fewer ones, for you to save a lot more cost, right? So let's take a look at the demo right now. So let's get started with the demo. So here now we're in the CelerData Cloud BYOC console, and this is one of the clusters I just created for this webinar. Okay, so before we actually dive into AutoMV, what does it look like? Let's first just run a query without any materialized view and see what it looks like here. Okay, so this is a SSB benchmark test, and here are the first three queries. The original SSB queries with the joins and aggregations on the fly. Okay, so this is actually the first one. The first query is just running, right? The result is extremely fast because we do have a pretty small data set, right? Let's wait for a bit for it to show up, and here it is. Let's take a look at the query profile. You can see that OLAP scan, right, on the data itself, and also we're running the join on the fly. We're running the aggregations on the fly. Okay, so there is like nothing that's pre-computed. Okay, so now we get that. Okay, so now let's create some materialized views with AutoMV. Okay, so to get CelerData Cloud to recommend materialized view for you, so you first have to create a tune space, right? And this is a space where you would submit all of the queries that you want, to base on, to create, based on them to recommend the materialized view, right? To accelerate those queries, right? So we did create this, okay? And now let's add all of the three queries into this tune space, okay? So, and now we can show recommendations from SSB1, which is a tune space just created. And you can see here, the materialized view has been recommended, accelerated all of the three queries, which is fantastic. Okay, so now let's take a look at the materialized view that's been recommended. Let's just put in this tab here. Let's name it MVs. Okay, so let's use SSB, the same database. Let's just name is too long. Just call it MV1. Okay, so let's run this for now. And one thing to notice here, we talked about earlier already. Also, it's the partition by, right? So AutoMV can not only provide you with a working create materialized view statement, they also recommend like which column to partition on, right? To maximize your performance based on your own query pattern. Okay, so now we have MV1, and now let's see if that thing actually rewrites. Keep in mind that we just directly copy paste this from the output right here. Okay, so yeah, with this materialized views in place, let's run this query one more time. We might wait for a few more seconds for this to show up on the query history. Okay, so here it is, 23 milliseconds, still very fast. And see here, instead of scanning from the data, it's actually scanning from the materialized view, and the joins is gone, right? The joins are gone. So, definitely it did successfully rewritten the query to point to the materialized view we just created by automatic materialized view, right? So this is the first little scenario I want to show, and the second one is how automatic materialized view can help you merge similar materialized views, right? If you have too many materialized views, actually pretty bad, right? because it wastes a lot of resources refreshing, and uses a lot of storage, and also it can be bad for query performance, right? When query rewrite with just too many materialized views out there, it can be slow if you have just way too many materialized views, right? But AutoMV can definitely help with this. So to demonstrate this, let's just let AutoMV create a similar but different materialized view. Okay, let's do let's create another tune space, right? And stuff more queries into it. Instead of query 1, 2, 3, let's this time just do query 1 and 2, right? So it's gonna recommend something that's different than the one we just had, right? So we just alter append, and now we have two queries, right? I'll use SSB again. And now let's get recommendation for this we just got. Let's take a look. So this materialized view is just being recommended. Accelerate both of the queries because we'll only put 2 in there, which is good. And recommended MV. So here it is. Let's put it here. Let's just call it materialized view number 2. Okay, so still has a partition by here. And the two are different. So let me show you right here. So this is the first one. And this is the second one. And let's find the difference. I see one more column here and pretty much similar, right? Except for that. So have we run it? No, not yet. So now let's run materialized view number 2. Okay, so now what we're gonna do is that we're gonna create another tune space. We call it materialized view merge, right? And next what we're gonna do is we're going to alter and populate this with this, okay, with all of the materialized views from the database SSB. Okay, so we just done that. And then we can select from the MV merge, which has the 2 MV we just submitted right here. And now we can show recommend from MV merge. So that's just one materialized view, right? That accelerates both of the, that can replace both of the materialized view we just sent to it, right? And let's see what the materialized view look like. Okay, so let's call this materialized view number 3, and let's run it. And just to be sure, let's delete the first 2 materialized views. MV1 bye-bye, MV2 bye-bye, and now we only have MV3, right? And now let's run the exact same query again. Okay, have to select the database. Okay, let's give it a few seconds for it to show up. Okay, query profile. Directly from MV, so it's rewritten again, right? So what we just demonstrated here was that we use AutoMV to merge the 2 MV that were not created, but recommended by automatic materialized view, right? So you can always keep your database clean, right? Not excess amount of materialized view in there, right? So that's it for the demo. Let's go back to the slide. So now we're back in the slides. So that's actually all I have today. So go ahead and try CelerData Cloud BYOC today. So at cloud.celedata.com, you can get a 30-day credit card free trial. And also you can, if you're not ready, and also you can join the StarRocks Slack channel, right, with this short link right here. And if you have any question now, that will be the time to ask. Let me see. Okay, so here are a few. So first, does failover group work across AZs? I think, yeah. So that's across availability zones, right? Um, yeah. So yes, it works across AZs. And a second question, suppose I need to compute the sum of values over the past 24 hour sliding window every hour. So every time 23 hours of data is reprocessed, which is true, which is waste, and how should it be rewarded, right? Um, how can AutoMV help? I think it can help, but not probably not with AutoMV, because AutoMV merely just recommends um, the materialized view, right? And this is more of like how like the strategy of your pre-computation, right? I think this is. Let me think. I think what you can do here is I'm just thinking on the top of my head. So I think you can aggregate by the hour, right? And when every 24 hour and you re-aggregate, on that hour mark, so you don't, recompute the 23, if you get what I'm saying. Um, if that make any sense. So you can like just like aggregate on every hour. You can have an hourly view, and then you can, do the aggregation, final aggregation on that data. It's gonna, I think it's not gonna like redo the 23, right? It should work. We can talk offline on that. I'll ping you in Slack. Okay, so another question. When is the next big release? So on CelerData Cloud, on CelerData, so we're gonna have another quarterly update the next quarter, right? It's something we're going to do consistently in the future. And with open source, there is a big release coming up with StarRocks. Probably gonna do a launch webinar around somewhere like January, is where you would expect 3.4 to come, right? A bunch of cool new features. You can search and take a look at the 3.4 roadmap on GitHub. Something like the vector index, that thing is in 3.4, and that thing is exciting. Um, yeah. So I think this is all of the questions, and it's almost holiday season. So happy Thanksgiving and happy New Year if I don't see you before that. Yeah, so thank you everyone for joining, and see you guys again the next time. Thank you, appreciate that.